let's take a look at the theory behind where this formula came from, because some people said, how in the world did they just come to figure out that that's how it is, x times the square root of 2? Well, one way may have been that they just practiced a whole bunch, like we did at the beginning, how we just practiced a whole bunch of problems and we saw the same pattern. Another way is that it does work if we just use some algebra as well. So what I'm going to start with is kind of what you have up here. I have a square, and there's a diagonal drawn through it with a right angle. So first of all, if it's a square, all the sides are going to be the same. X, 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 x. Now I'm going to break this apart. Now it is a square, so we have all four right angles, making this 45 degrees, this 45 degrees, and obviously this one also, and this one also. We're going to kind of take this bottom triangle and pull it out. So really, this is what I'm working with. This is x, this is x. So we have a 45, 45, 90 triangle. If our sides are the same, x and x, we want to find this piece. So we can use our Pythagorean theorem, a squared plus b squared equals c squared. Now in this case, our two sides are variables. They're both x. So it's going to be x squared plus x squared equals c squared. Here, and the reason this is theory is because it's all with, there's no numbers involved. We're just using variables to represent it. So here I put the 1 in front of each. These are like terms, and I'm going to get 2x squared. I'm going to add 1x squared plus 1x squared is 2x squared. So I have 2x squared equals c squared. Now I take the square root of both sides. We're going to, these will cancel, c comes down, and just like we learned, our one property means that you can put the two things being multiplied underneath the square root together. We can also pull them apart. So square root of 2x squared is the same as the square root of 2 times the square root of x squared, like we do when we simplify using these perfect squares. The square root of 2 we don't know, so that stays the square root of 2, but the square root of x squared is going to come out. So now we have c is equal to x times the square root of 2. And look at that. That's exactly what we found. X squared root of 2, x squared root of 2. So for any 45, 45, 90, not only do the numbers work, but the theory behind it works also. And that's where that goes. So let's try with the 30, 60, 90 and see if a similar thing happens. With this one, we're going to start with an equilateral triangle. So an equilateral triangle means that all of our sides are the same and all of our angles then are the same. So if all of our sides are the same, this is going to be x, that's going to be x, that's going to be x. Okay, I'm going to hold off on identifying any of the sides just yet. We're going to cut this down the middle. Because it is equilateral, this is 60 degrees, this was 60 degrees, and this whole angle up here is 60 degrees. But when I cut it, now this is 60 degrees, the whole thing, but just half of it's going to be 30 and this half is 30. And this line straight down the middle makes a right angle. So if I take a look, I'm going to pull out, just like we did with the other one, I'm going to pull out just half of it, because we said a 30, 60, 90 is the one we're looking at here. Because these both, notice, are right triangles. So we have a right angle here, the 60 here, which fell right here, and the 30 here, which fell right there. Okay, let's keep that off to the side for a moment. Now, let me call each of my side lengths 2x, just for fun. 2x, 2x. Okay, it's going to make it a little easier if we do it that way. So now, this side I can start labeling some of the side lengths. This is going to be 2x. This bottom half here, the whole thing was 2x. So one of them, one half of it's just going to be 1x, or just x. But the long leg, not the hypotenuse, the long leg that cut down the middle, this we don't know. So we're going to use our Pythagorean theorem to figure it out, using all the theory. So my one leg is x squared. God bless you. The other leg I don't know, which is b squared. And my third side is 2x squared. Now I need to put that in parentheses. Okay, 2x squared. So a squared plus b squared equals c squared. X squared plus b squared equals, now here, side note, 2x squared is equal to 2x times 2x. 2 times 2 is 4. X times x is x squared. So this is equal to 4x squared. You may have remembered that when we learned our exponent rules, that we distribute that squared into both components. We get 4x squared. So that's really like 2 times 2 times x times x. So now I have x squared plus b squared equals 4x squared. Sometimes when you're doing it like this theory stuff, it can get confusing because you forget what you're trying to get by itself. In this case, we're trying to solve for b. We want to know what this length is. So my next step is going to be to get rid of anything on the side where the b squared is. So I'm going to subtract x squared. That's the next thing I'm going to do, because I want to get b squared by itself. B squared comes down. 4x squared minus 1x squared, those are like terms. I get 3x squared. And now I'm able to take the square root of both sides. This cancels, gone. So b comes out of the square root sign. Now I can break this into two separate terms, the square root of 3 and the square root of x squared. So I do that. B then, square root of 3 I don't know, but the square root of x squared does come out, and we get x. So I find that this missing side is really x times the square root of 3, and that matches our pattern. X times the square root of 3 is the long side. The little side at the bottom is x, just because it's half of what our equilateral triangle was. And our hypotenuse stays at 2x. Okay? So that matches the form. Now if you hadn't used the sides as 2x, you may have just labeled them x, and that means everything would have been half. So you would have had x, 1/2 x, 1/2 x times the square root of 3. It's just more convenient to label them 2x. But that's the theory behind it. Hopefully you were able to follow it. You will not be tested on either of those theories, but I want you to see where the stuff comes from, because sometimes that makes it less like foreign to you. So good job, and thank you for listening through it. Have a good one. Bye-bye.